Next, we're going to apply how we can use the molar mass to counting molecules. So just like we saw previously, we use the mole in order to count atoms. The mole can also be used to count molecules because the mole is able to count anything. So remember, the mole is just like a dozen. A dozen always represents 12. A mole always represents Avogadro's number. So therefore, it's used for counting. So in this case, we're counting very, very small objects that are not tangible. So we are using the mole in order to count molecules and atoms. So we are going to use mass in order to determine the number of molecules in a particular amount of a substance. And by using molar mass, that allows us to convert the mass into moles. And then by using Avogadro's number, we can convert the moles into molecules. Okay, so let's read this question. It says, an aspirin tablet contains 325 milligrams of the active ingredient acetylsalicylic acid, which has a chemical formula of C9H8O4. The question asks, how many acetylsalicylic acid molecules are there? So let's think about what we are given in the problem. Our given value is 325 milligrams. Okay. And we were saying that we need to use molar mass. Now remember, molar mass is grams per mole. So if we're starting with milligrams, we need to convert those milligrams first into grams before we can use molar mass. Okay, so let's write our plan. Our plan for this problem will be to convert 325 milligrams of our C9H8O4 to grams, and then from grams to mole, then from moles into molecules. Okay, so don't mix up the abbreviation of mole and molecules. Mole is always MOL. Molecules must be written out as its full word, okay? Because if you write MOL, that represents moles, not molecules. So remember to be using the correct units as we're making these conversions, okay? All right, so now if we're going to be converting between grams and moles, we said we need molar mass. So we need to calculate the mass of the elements that are made up in our active ingredient, acetylsalicylic acid. So that's 9 carbons, 8 hydrogens, and 4 oxygens. So at this point, we should be familiar with how to add together those masses by looking at the periodic table. So I'm not going to go through showing that entire calculation since I was showing that in the previous slides. But just remember, you will be adding together 9 carbons, 8 hydrogens, and 4 oxygen atoms. And the molar mass or the masses come from the periodic table. So carbon is about 12.01, hydrogen is 1.01, oxygen is 16. So multiply it by each of the number of elements and then add the masses to give you the total, okay? So once you have the molar mass calculated, what you should be getting is, 1 minute here. what you should get for the molar mass of the aspirin is 180.17. Okay, so a molar mass is going to be 180.17 grams per 1 mole. And that's of our C9H8O4. Okay, so this is our molar mass that we're going to apply. So I'm just going to write it small over here just so that I remember it, but I need more space to do my conversion here. So I'm going to just jot this down here so I remember the number. So now, when we begin our conversion, we're going to start with the given information. The given information is that we have an aspirin tablet that contains 325 milligrams of the active ingredient. So we're going to start with 325 milligrams of C9H8O4. How many milligrams are in a gram to be able to convert between milligrams to grams? There are 1,000 milligrams. Whoops, put too many zeros. 1,000 milligrams in 1 gram. Okay, so that allows us to cancel milligrams. Next, we have grams. We want to change grams into moles. In order to do that, we use the molar mass. If we have grams on the top, we need to cancel grams on the bottom. So we're going to put 180.17 grams on the bottom per 1 mole on top. Okay. And then our final step, now that we've canceled grams, our final step is moles. So from moles to molecules, we apply Avogadro's number. So we put moles on the bottom, 1 mole on the bottom, and then we put Avogadro's number on top. 6.022 times 10 to the 23rd molecules. Okay. And all this is of our active ingredient, acetylsalicylic acid, C9H8O4. So I didn't have a lot of space to write in the chemical formula in each step, but you will need to start getting in the habit of writing out the chemical formula with each unit, because eventually, once we get into stoichiometry, we're going to be changing between substances. So in order to keep track of the substances that we're working with, we need to include the chemical formula with the units. Okay. So that's why I'm always including the chemical formula along with the units. But since I was running low on space here, I didn't write it out in every step. I can fit it here though, but that's okay. Okay. So what we're going to do now, once we cancel our units, we see that we've got to molecules, which is what our question asked for. How many molecules are there? So then once we've gotten to this part, we can use our calculator. In our calculator, we're going to place 325 divided by 1,000, divide that by 180.17, and then multiply that by Avogadro's number. Remember to use parentheses since we have an exponential number so that it does the correct order of operations. The answer that you should get, there's a lot of digits there, but I'm going to round. The least number of significant figures in my calculation is 3, okay? Remember, this number is an exact number because it is a definition. There is 1,000 milligrams in 1 gram. So an exact number, you don't count significant figures, okay? So the least number of significant figures is the 3 significant figures here. Okay. So I'm going to round my answer to 0.09 times 10 to the 21 molecules of C9H8O4.